The Future of Hydropower, an In-Depth Perspective by Andrew Bongoyan, Nate Chavez, Matthew Ducato, and Nathan Dryden. Should hydropower be a more prevalent energy?
Hydropower, also known as hydroelectricity, is water flowing from higher to lower elevations in rivers and streams that can be controlled by dams and reservoirs and can be used to produce electricity. Hydropower is a type of renewable energy as it is constantly renewed and restored by the sun. Since hydropower is a type of renewable energy and provides many benefits such as flood control, consistent water and energy supply, its effectiveness and use is strong. The different designs of hydropower vary, but there are two main types of hydropower productions: dams and run of the river. These two graphics illustrate these two types and how they work. Now, what exactly is the problem with hydropower? Although hydroelectric power reduces carbon emissions by providing clean energy, hydropower also causes significant problems from environmental, futuristic, financial, and technological standpoints. What does this all mean? Well, hydropower inevitably has detrimental effects. One example, as stated by Richard Stone, says that China's Three Gorges Dam submerged wholly or in part 13 cities and 466 towns, displacing roughly 1.3 million people and triggered thousands of landslides. This quote goes to show the severe environmental defects caused by hydropower. Additionally, hydropower also has significant financial costs. Next slide, please. This graph, according to Renewables First, a hydro and wind company, shows the cost to build and operate basic hydroelectric systems. This graph also shows how much a plant produces and how much it will cost to produce with how much the plant produces. Go back.
Next slide, please. With all these rising costs, the implications of hydro dams must be great and large, right? Contrary to that belief, projections of the hydropower plant have shown that its price doesn't correlate with its production of power. As reported by a professor of environmental economics at the University of Navarra and a PhD of mathematics at Complutense University of Madrid, Keba Salan and Emilio Cerda say, quote, reductions in productions by the end of the century range between 30% and 49%, and between 10% and 31%. This trend is not, nevertheless, inconsistent with historical data, which already shows a significant decrease at the flow of the plants. Next slide. Developing countries face problems that most developed countries look over. What will it affect geographically? This image presents the fragile state that these communities are placed in. Next slide. Hydropower tends to make floods due to a glut of water rushing through the dams, which is depicted in this image, in which farmers would be impacted with destroyed crops, as reported by K.A. Shaji, a well-seasoned journalist since 1994. How can we limit or change this? We have an answer. Next slide.
Our solution is to have more hybrid PV-PSH system. A hybrid PV-PSH system stands for photovoltaic, pumped storage hydroelectric, and it is a standalone power system. The way in which these are made and installed is displayed in the video on the left. PV panels, which are photovoltaic or solar, are incorporated into the hydro plant mainly in two different ways. Installation of PV panels on the downstream face of a dam, an option only possible in certain plants where the face of the dam is below 40 degrees. The other is floating PV panels on the water surface of the hydropower reservoir. These make hydropower plants go from a capacity factor of 50% to 100%, as said by Emmanuel Carranza, who has a post-PhD and is a researcher at European Commission and is an expert in civil engineering and hydropower, where, quote, the capacity factor of the hydro plant is the ratio of total generated energy to the maximum energy that can be generated if the hydro plant would always work at its maximum installed capacity. Furthermore, these hybrid systems are necessary, according to Helena Ramos, who has a PhD and is a professor at Technical University of Lisbon. As fossil fuels presence being wiped out by renewable energy requires, quote, distributing installations widely and using a range of different intermittent energy sources, especially those that are partially complementary. Moreover, she says, trying to further prove her point about these being necessary, quote, different energy resources can be combined, building an integrated hybrid energy system that complements the drawbacks existing in each individual energy solution. Therefore, the design goals for hybrid power systems are the minimization of power production costs, purchasing energy from the grid if it is connected, the reduction of emissions, the total life cycle cost, and increasing the reliability and flexibility of the power generation system.
The feasibility of this solution is proved by its ability to be applicable in different situations and by choosing the right technologies and components. For example, Jur Margetta, who is a professor with the Faculty of Civil Engineering and Architecture at the University of Split, says that this system is widely applicable in different climate conditions and adjustable to local characteristics. Therefore, it is a promising alternative for the sustainable production of green energy. Furthermore, Helena Ramos at the Technical University of Lisbon also says that hydro, wind, solar, and pumped hydro storage, which is PHS, as hybrid power solutions constitute a realistic and feasible option to achieve high renewable levels, considering that their opponents are properly sized. Finally, according to Masui Shabani with the Mechanical Engineering Faculty of the University of Gulian in Iran, says that the appropriate selection of sun tracking technology in a hybrid PV-PHS system can lead to savings of up to 18.2%. Next slide, please. There are several implications and limitations to this solution. This graph on the left shows the energy output compared between floating PV panels, which is our solution, versus normal PV panels. As already mentioned, technology of these hybrid systems can make hydropower more cost efficient. Furthermore, according to Hadriante Puspartini from the Department of Land, Environment, and Agriculture and Forestry at the University of Padova, states that the conclusions of this research are about the different types of CHP systems, which is combined heat and power systems, and the relatively large, although limited, CHP electricity generation. While CHP systems are capable of fluctuating their heat generation, the flexibility is often not used in practice. Although some of the implications of introducing this type of power source are generally positive, there are still several limitations. For example, Puspartini goes on, saying that the costs of hybridization, which include reconstructions, infrastructure, and other factors, will prove to be a difficult and potentially risky implication. If the hybrid systems do not work or have flaws that need attended to, even more costly repair will be necessary to upkeep the systems. Additionally, such systems may not be as reliable at our current technological advancement. A breakdown or error can become very expensive and detrimental to the system. Furthermore, Puspartini says that conventional drawbacks of the use of PSH are a lack of locations from big storages, a long lead time, the effects on the environment, and relatively high investment costs. Of course, there are several factors that go into how a problem should be solved, and these are some of the potential benefactors and drawbacks of this solution.
Although the average hydropower plant is effective in reducing harmful emissions and its potential for long-term sustainability, opposing studies and reports display the negative impacts that hydropower has, such as regional displacement in poor communities and subpar efficiency. The current state of hydropower has shown that it's defunct and requires a solution in order to have sustainable energy use. From the previously mentioned K.A. Shaji, who wrote about the affected communities, quote, "There are victims of the flood and landslides that occurred in the last 3 years and yet to survive the impacts of nature's fury," end quote. On the other hand, hybrid systems have a great adaptability and the potential to reduce running costs. David Newland is a well-educated writer with multiple articles about the energy sources. As stated in his article, Hydroelectric Power 101, quote, "However, the Energy Department reports that there are 80,000 dams in the country. Only 3% are used to generate power." Retrofitting those dams with hydroelectric systems could add an additional 12 gigawatts of electricity to the national grid. Our current hydro dam systems are harming the globe, and the call for establishing a new hydropower system is now more important than ever. Thank you for listening.
Terrific. Thanks, guys. I got a couple of questions for you, and I'm just going to run right down how you guys appear on my screen. So Matt, you'll be first. Matt, give one specific way that your thinking changed about your project as a result of learning about Andrew's research. Like, how did his impact the way you understood this problem of hydroelectric power?
All right, so what I learned from Andrew's research was that the overall sustainability of hydropower. And through the statistics of his quotes, I was able to see the effect that the technology had on the influence of other lenses. Also from his findings, I determined that the hybrid systems are the solutions to solving the problem due to its reliability and much higher because of how applicable it is in different conditions, as said in the quote by Hoover Margetta.
Fantastic. Thanks for that. Okay, Nate Dryden, you'll be next. What was an example of a compelling argument from one of the other guys' reports that you guys decided to exclude from the final version of your presentation? So, you know, something they said that was compelling, but it just didn't make the final cut.
So we decided to get rid of Matthew's limited adaptive genetic algorithms because it pretty much genetic algorithms are a set of outputs that are designed for any system really, and it takes the outputs of those and pretty much adapts based off of them to make a perfect system. And we decided to leave it out because it was too broad, and it could really be for any energy system or even outside of energy, it could be used. And it wasn't solely applicable to hydropower. And also the research we had done on it, there was not a ton based solely on how it affected hydropower. And it was more 2 to 3 articles, and we had lots more evidence for the solution we chose, which was a hydropower PV-PSH hybrid system.
Hey, thanks, Nathan. Okay, my third question is going to be for Andrew. What was a way in which your team's resolution makes you think differently about your own research? Like, how did the final solution compare with what part of it you played?
I think I think that our conclusion about using technology to hydropower's advantage made me think about how complicated systems to help improve hydroelectric power are often overlooked for the simple and not as effective solutions. When researching for my paper, I found a lot of sources talking about potential adaptations, including a PV-PSH system, and I found a majority of authors, including professors of engineering at universities, would only talk about small changes. Some of these include limiting variation orders, which is when the construction of dams goes differently than planned, while other authors talked about planning the hydro plants more carefully. Although these are still effective, we all found that more complicated hybrid engineering systems was much more effective from both an economic standpoint, but also from all of the other factors that played a big role in how we chose a solution.
Terrific. Thanks, Andrew. And then the last one is for Nate Chavez. If you guys had a fourth or a fifth team member, right, like one more person to add on to your team, what area do you think they could have researched that would have helped with your final conclusion?
Okay, so if we had a possibility of another team member, we would most likely utilize the ethical perspective. It would be a much more helpful in researching about the problem and like what exactly like is happening to these people. And like some of these examples could be the impacts on poor communities. So like we described previously about displacement, destruction, and maybe we could go in depth more about like how it could affect deforestation and maybe like go more specific into how like workers experience with the hydropower plants and much more. This could either allow or limit the possibility of the hybrid system, since a possible con, such as what I described about maybe workers could report on low wages on the long-term project in the poor conditions, and that could factor into the feasibility of it.
Fantastic. Thanks. Hey, you guys can disconnect and come on back in. Nicely done.
Thank you.